Doctori, tutto a posto? Welcome back to a new episode of Sane C Libraries. So what is Sane C Libraries? Well, it's a set of platform abstraction libraries for macOS, Windows, and Linux that is fast to compile, it's bloat-free, it's simple and readable, easy to integrate with no use of the C++ standard library. No third-party dependencies, and you can check it out. It's published on GitHub. It has a MIT license, so make sure to check if maybe that's a library you may like. So what are we going to do today? Today, I would like to create an abstraction that is called the streams that I have. It's something that I have seen created in Node.js. It's actually one of the basics, very old abstractions that have been existing in Node.js since I think the beginning. More or less, really one of the first versions already had it. I don't remember exactly which one. And I always liked it because it's a way to take an asynchronous source and one or multiple asynchronous sinks, so consumers of data, and connect them to allow fast streaming of data without overusing too much memory, without really, allocating too much. So let's imagine you have like a huge file, which is 10 gigabytes or I don't know, 50 gigabytes, whatever number you think it's big enough. And you wanna read it and pipe it somewhere else. If you do it like the standard way of, synchronous way, you load the entire file in memory, that's going to take a lot of memory, especially if you have multiple concurrent requests. So you can say, okay, I will do it chunk by chunk. But even in that case, when you try to do it on an asynchronous workflow, so when you are like sending a request and then waiting for the request to be fulfilled, then it becomes hard to, let's say, handle buffers that you may want to be placing in between. So let's see how Node.js is solving it. So Node.js is telling that a stream is an abstract interface to work with streaming data. And this is more or less what I said. There are many objects that are provided by Node.js. And for example, HTTP server is one of them. So it's providing requests and responses as stream abstraction or the standard out of process and so on. We have different types of streams. We have a readable stream, which is a source of data, a writable stream, which is a destination of data or a sink, if you want. We have a transform stream, which can take incoming data, change it, modify it, and push it, downstream to consumers, so to writable streams. And then you have a duplex, which is a stream that is both readable and writable. Let's see. So this is the Promises API. You can create pipelines. So you can, for example, read this file. You can pipe it to a zip transformer, gzip transformer, and you can obtain a tar gz file that you can push it on another file in this case. So that's more or less what we are trying to do. Of course, this is a very extensive API, the one we have in Node.js. We want to do definitely something simpler, more sane if you want. And I have a lot of changes that I would like to be doing because many things do not make sense in C++ or are simply features that I don't think are worth, or they are backward compatibility features that are in Node.js and make no sense on an API that you are bootstrapping from scratch. So the object mode, for example, is one of them. So streams are typically processing bytes, but sometimes you may want to be using objects. They may be emitting, JavaScript objects, which we don't care. We don't want to create like a stream abstraction to emit objects, especially C++ objects. That would make very little sense. So this is definitely one of the features that we will be dropping. Then we have buffering. So this is really one of the most important, because if you ask me, okay, it's not that hard to create like a source and a stream example where I'm reading from a file and writing to a socket, for example. And that is true. but can you make it such that you have a buffer for both the readable and writable side, and maybe where you can pause the reading side because the writing side is too slow, and so you need to let's say pause the reading side, because otherwise you're going to be allocating way too much memory, because the reading side is reading a lot more than you are writing. So this is exactly what all of this buffering is about, and this is something we want to be doing. There is this concept of the high water mark, that it's basically I think I have some notes that I've been writing. Let me see. Yeah, this is all I was talking about. So this high water mark, so the concept I just described is the back pressure. So when you have like the writing side that is slower than the reading side, then you definitely, this is called back pressure, and you want to make sure that the reading side, it's going to be paused. Then you have the high water mark, which is exactly what triggers the back pressure. So you have this is conceptually like a container of water. So when you go above some level, some watermark, actually, that's going to stop the flow of data. And so this is basically a memory limit, if you want. All of the streams are based on the event emitter in Node.js, which means they have events that you can listen to. So you can listen for pausing events, or when a stream is ended and things like that. There is an abstraction that is meant to be implemented by whoever is creating a readable and writable stream, and you can see API for stream implementers. So you can construct basically you have this construct, you have this read, and you have the _destroy. I think I'm going to do this a little bit different, but the main one is really this read, that in Node.js is taking the number of bytes you want to be reading. I plan to do things a little bit differently, but for now that's all right. And every time you have data, you need to push it on the stream. So you have this push, and when you do push null, then this is like a signal for ending the stream. That being said, well, you can destroy it, which means, just terminate the stream and, dispose it, all of the, resources that are underneath. So like a socket or a file descriptor. You have the end method. This is for writable streams, which it's going to say, okay, I've been finishing writing to the stream, and I will proceed disposing it, very likely. And what else do we have? On error, yes, as this is like a completely asynchronous construct, when you have an error, you cannot return an error code, so you need to have an on error callback, or actually an event emitter here. So it's like a set of listeners that you can add some callbacks to and be notified about errors. So it also, this abstraction is able to take care of synchronous and asynchronous flows. It has two ways of reading data. One is providing the on data. I think it's called two reading modes, yes. You can basically have a data event handler, which is just an event providing you buffers of data. And then there is another way in which you can basically poll for data. You always have an event which is called a readable event, which is this one. And once you say that, once you receive this readable, you can call read until read returns like a null buffer. They are, kind of overlapping if you want. There are historical reasons why Node.js has both of them. I don't think we need to support both, so I'm just gonna support on data. Eventually, if we need to implement like a readable and read API, that can be done. But it would, I think it would be making the code, state machine a little bit more complex. It's probably not worth it. So these are like the constraints that I've been imposing myself. So we are not supporting this readable plus read, so readable event and polling read type of reading mode. We will not support the object mode. We will support the on data event, which is the data event handler. So you have a readable, you say on data, you get a chunk of bytes, and you can do whatever you want with the chunk of bytes. And this is important. I want to make this entire abstraction allocation free. So all of the data in the buffers needs to be specified from the caller. So if the caller wants to use an arena or put things on the stack, or whatever allocation strategy the user thinks is the best, he or she should be able to do that. So this will be able to run with a fixed memory budget, and I still want to try to support both the sync and async generation. So what does it mean, sync and async? If we go into the example, where was the example? Let's go here. Example, implementing a readable stream. So this is, for example, the read operation. So it's calling fsRead, and you have a callback. So this means that the callback is called maybe later when the data is available. So this is pushing data asynchronously. So from the moment this is read, this method returns, but no push is called. At some later time, push is called because this callback is invoked very likely by the asynchronous event. The event loop. It will asynchronously push data on the stream. So that's an asynchronous stream. But if we use like a read sync, which could be just like fopen and fread on C or C++, then we are going to push the data. That becomes like a synchronous push, which means the push happens before the _read operation, which I think I'm gonna call async read because I don't like things starting with underscores. So if we call push before this async read terminates, then we are doing a synchronous generation. That being said, what else do we have? I will call the classes AsyncReadableStream, Pool, and Readable Stream. I already been thinking about them. So we will have like a view over bytes that will be our AsyncBufferView. We will have a pool of AsyncBufferViews, and we will have this readable stream. So for today, only readable stream, hopefully. Maybe not even that, because I think we'll see. We have many more things to implement. The operations that need to be able to do are like start, pause, resume, and destroy. And in the implementation, we need to have the push, which is the equivalent of the Node.js push, the push null, and I don't like to use like push null. We'll just call it push and, or maybe just and, I don't know, we'll see. I would like to use a reactivate method to let the stream communicate to the state machine that it needs additional reads. This is done differently in Node.js. Node.js is, for example, doesn't have the start method, because as soon as you add something to the data and event, or you call a resume and so on, the start is automatically done and it goes into flowing mode. I don't think that's very intuitive. I prefer to have an explicit start method, so you don't accidentally start generating data because you attach an event. To me, that doesn't make much sense. So we will have like an explicit start method, and there is this next tick that I think I forgot to mention. So when in the Node.js, when they have some, they want to execute some let's say piece of code after an asynchronous handler has been calling into the stream abstraction. So let's make it practical. I want to execute from inside my stream implementation some code to change the state after this callback is invoked. This callback will somehow signal to the stream implementation that has been called by calling this push method. But then, push is executed. And so inside push, very likely in Node.js, we will register like a next tick continuation, so a callback, that will be executed on before the next IO cycle, but after this callback is finished. So if there is additional code, like in this case, there is no code after push, but if there is additional code, you will have basically push, the code executing inside push, then it will, the control flow will go back into this callback. It will execute whatever code it's here, and then whatever callback has been pushed from the, has been set as next tick from the push method will be executed. I find this a little bit confusing, as you may imagine, because even just describing it, it's confusing. So if you have not been able to understand what I just said, that's normal, and that's exactly why I don't want to do that. I know this mechanism very well, and so well that I prefer not to have it, at least for now. Maybe I will regret it, but let's see how it goes. So in my abstraction, I will explicitly ask when you have like a situation like this to basically add end of method marker, which I called reactivate, where you will be telling to the stream abstraction if you want to be reactivated or not. So if you want the read to be called again, basically. And then we have the emit error. So I already have been doing a little bit of homework, as you can imagine, because this is not something you can improvise on a video. So my idea is to have a state machine like this. This is not complete because some states, like the error state and in some ways even the destroying state, are basically reachable from every other state. So if I try to throw them, that would just not become like an understandable graph anymore. So I've been concentrating on the more important states and just putting the error and the destroy state here, because that is something that probably I will not even be able to make it right now. So let's see. So the stream, the readable stream, this is a readable stream, starts, stopped, it will be initted, and then it becomes, can read. It's in a state where it can read data. Once it's in the state in which you can read data, you can start it, and after you start it, then you are in reading mode. When you are in reading mode, two things can happen. You can have a stream that is a synchronous stream. So if it's a synchronous stream, it will do a push at some point with some data. And after doing this push, it can do basically, it can ask for more data by calling the reactivate, which we have seen before. So it will go into the sync read more. So this becomes, again, something where you can go in the reading mode. Or it can signal like the end of data, like I am emitting data, now the data is finished, and I'll just go into the ended state. Let's take the other branch. So let's say we have an async stream. So it means that we will be calling the read operation, and the read will not be pushing anything. So we will know, okay, this stream will be sending us something asynchronously. So we go into async reading mode. And at some point, the stream will be pushing something. So that will be an async push. So this is very similar to the case we have just seen here. Like this, like when calling this push, we will be going into this asynchronous async pushing mode. And you can be pausing. So if you try to pause, look, when you try to pause when you are doing a synchronous push, you can go directly into paused state. But when you are in asynchronous pushing, you need to go into pausing state and then paused, because you still need to basically stop the stream. You cannot just like immediately pause. You need to be somehow doing a cooldown of the data and make sure that it's really stopping emitting the data. Otherwise, you will be losing the data when if you immediately hit pause and then you get additional callbacks arriving, that becomes a problem because you will be dropping data. And in many cases, from many states, you can go into this destroy mode, which is the state in which you go when you are not really, you want to end stream prematurely. Like you have a socket, it's connected, and you don't care about anymore about the data because you are, I don't know, closing a page, then you can destroy it. You will never receive the ended. you will receive the ended state if someone on the other side of the socket will, close the connection, and you will receive the ended. I hope all of these makes any sense, but if not, I have been, these are like the states that you have seen over there. I will try to somehow make them work. So let's go into the library, like this async library. That's probably not the best place where this should be going, but I guess for now that's fine. I can add this async streams.cpp and async stream of streams, I don't know, streams.h, and we can add an async streams test .cpp. I can generate projects so that we already have something. Oh, that's way too much stuff. I should have been choosing another test with less stuff. That's way too much. Anyway, yeah. Wait a minute. I don't have. Oh, let's use something else from scratch. So async test becomes async. Oh, I'm getting confused. Hold on. I need to remove all of these ones. Remove. Yes, run async test. That's what we want. So async test becomes async streams test. And all of these, we can remove it. Why am I wasting so much time just to create a very simple test? I don't know. I've just been picking like the worst possible example because it was like the most complicated one. Anyhow, this is done. So I don't need all of these. I probably will need the async streams. Okay. The section basic. Let's see if this is compiling. No async event loop, of course. Okay, let's go into SC tests. So I can add this test, SC test. So I can add it to the list of the tests to be run. So if global console, this is my way of hard coding to run the test. I even have some command line arguments, but I don't know, I'm just lazy and I do it like that. Run async test, and we can make it run async streams test. Okay. So I think before even starting, I need to implement some sort of event emitter, like class, which is not very hard to do because you just want to be registering some function, like std function like objects, and then you want to be calling invoking them when someone is emitting an event. So let's try to do that. Event, this is my event test. So let's say namespace sc, then I will move it into its own header. Struct event emitter. This is going to be long. I don't think I will be able to make it into this video before it becomes way too long, but let's try it. Struct event emitter. I think I would like to make this fixed size. So let's make it template with some maximum number of emitters. You don't really need to be able to register like an unlimited amount of emitters, because if you are of, let's say, listeners for an emitter, because if you do that, then you are definitely doing something wrong. So I'm going to do, to make it like capping at some maximum number of events. So this is in foundation, but it's 2 directories above, and it's function. Function, how do we need this function? Event emitter, void t. Oh, we need to make this with a variable number of arguments. I can never remember the number, if the triple dot goes before or after. How do we call them? Listeners. And then we have num listeners. Okay, that looks good. So I can have an event emitter of, I don't know, 5 int emit int emitter. Yeah, that's better. Yeah, this compiles. So I've been putting the triple dot in the right spot. So when building the event emitter, by default, this is fine. So I want to have like an add, well, this should be probably fallible, so no discard bool add listener. And well, we need another template here, because you can have, well, it depends if we want to be adding a lambda. Let's make it add a lambda. Template, type name lambda. So you have a lambda. And I can make listeners num listeners. Well, if num listeners is equal to n, return false. Otherwise, num listeners, we can make it equal to lambda. No discard. Yeah, we can even move it. So let's say ctest expect int emitter add listener int value, and we can say int my value equals 0, and I'll say my value equals value. So we can expect that my value is whatever, I don't know, 9. Whatever value we are making, we are passing into the emit function, which we have not been creating yet. But the expectation is that when I emit, this will get called and it will save the value in my value, and I can check it. So let's implement the emit, void emit t value. Should probably make it, yeah, we'll probably need to make it both in the double ampersand and the single one. So for all listeners, num listeners idx listeners idx dot value. Yeah, that could work. or probably not, or an expected value. Can we forward them? Yeah, probably yes. That's right. Yeah. So we are getting, this is executed, right? Yes. So I think this is okay for now. I probably should be adding like a IDX pointer that it's returning me the pointer if it's non-null, and then like a remove listener at index where I can take the index and remove it. And you know what I'm going to do is, yeah, like listeners index equals, default constructed function, and then listeners, like num listeners -1. So this clearly can only be done if num listeners is bigger than 0. So I will just move it, the last item here. So this means that the sequence in which the events get called, the listeners will get called, is non-predictable, or it's not guaranteed, which I think it's good. You don't want to be relying on that. Where is my IDX? Well, I guess I can fill it. If IDX, then IDX equals num listeners, and remove listener at index. Yeah, if num listeners is bigger than 0, you want to be moving it where you just, oh, I can even, yeah, I can do that. Of course, we need to range check this. If index is, and index is less than num, that was, yeah, it should be less than num listeners. This is getting way too convoluted and we don't even need it right now. So yeah, let's just keep it like this. All right. Yeah. And in either case, we need to make num listeners -1. So let's add another one just to make sure this is getting invoked. My value 2. So my value 2 is value times 2. So my value 2 needs to be 9 times 2. And let's say I'm removing the listener at index. And index, I can add it here. Yeah, this is void, so you don't need to check it. If I emit this again, now I'll make it 10. This means my value will be 10, but my value 2 will still be 9 times 2, right? Perfect. So this is our basic event emitter. I think I'm going to, yeah, make this a little bit better, but for now that's good enough. Adding the proper constructor, destructors, and range checks, making sure that I'm not like forgetting about some edge case here. That's going to be good. So this is not allocating anything. That's like a fixed buffer. You're adding things to it until you have room for it, and then when you remove stuff from there, it will move the last item where you ask to remove the, yeah, so we need also to make sure that this is different than listeners. Yeah. That's probably better. Okay, let's go forward. So this can go into like an event class, which can put it into internal event.h. Event.h. And I can make it event.h. I need to regenerate the project, probably. Generate projects. So I can include internal event.h. That's where our event will be. Now, async readable. Async readable stream. What was the name that I've decided? Readable stream. Oh, we also need the buffer view in the pool. Well, let's do the buffer view in the pool before. So what will be our buffer view? I think we will have just a span char of data. Yeah. Then I will need to use, there's the strong ID class that I can use to generate a strong identifier. Just because I want to refer to this buffer view, not with pointers, but just with an identifier. But you know, in C, you would just use an integer. In C++, you can tag it so that you don't mix and match unrelated IDs. And that's where I'm going to use this strong ID. So let me create a tag for it, and I can say my ID is strong ID, not string ID. So I can take it from foundation, strong ID, if I can only type things properly, if I could only. Strong ID type is our tag. So this is just a dummy type that is used to create this ID as a unique type and has like an integer identifier. This is ID type, which is by default an int32. So at the end of the day, an ID is just an int, but it has this, you know, type tag that it's making sure this is, you know, the right type of int. You know, typical things you do in C++ sometimes. Now I want to create a buffers pool. Yeah, async buffers pool. Maybe let's place them down. So my buffers pool will be a span of AsyncBufferView. Yeah, buffers. I don't know if I should make it public, probably not. I think the buffer view should have a reference counter, and that's clear because as we have an asynchronous mechanism going on here, we never know when something, you know, if some request is going to finish earlier or later than another one, so we need a ref counting. But I will make it like manually ref counted. I don't want to be using C++ ref counting because that becomes really involved once you start using events, because then you will be forced to attach the buffer views to events, and you will immediately lose visibility on when those ref counts gets incremented or decreased. So we will do it like the C way, which is, you know, very in the style of Sane C++. So Sane C++, really this is like the philosophy. We take from C++ like features that I like, but you know, it's not just that I like them, it's that I think they are bringing something to the table. Using this strong ID, it's making sure that wherever I use ID, so I will use like ID, my buffer ID. This is, you know, by all means, it's just an int32. But if I create another class that has another ID, I will never be able, my texture ID, I will never be able to mix them and use one instead of the other by mistake, because under strong ID, this will have two different ID types. One will be AsyncBufferView ID, and the other one will be async texture ID or whatever. So that's the good part of C++. The bad part is this like automatic shared pointer like ref counting. That is something that I like to avoid, especially when using asynchronous events, because it becomes very hard to understand why your ref count is not going to 0, or it's very hard understanding why your ref count is going to 0 while you were thinking it should have not been going to 0. So, I've been calling event emitter. Maybe that's not so good. I think I want to just call it event. Yeah, event is a lot better. So, I don't know, I will figure out some decent number of events that make sense here. So, well, that's not where I want to create them. Struct async readable stream. That's where I will be placing my events, not in the buffer pool. Buffers pool. So this has methods to ref buffer. So you will be passing an AsyncBufferView ID buffers. Unref buffer. What are these doing? What data structure should I be using here? So someone should be able to pass me like a linear array of these buffers, which are just spans of data. And I need to be able to access them in constant time. Yeah, it's all fixed. So I can use, I can just use a span, which is basically a read-only, not an owning array. Yeah, so buffers.get, and here I need an int type. I can use buffer ID. Can I get it? Yeah, doesn't work because I need to use the identifier, which is the actual int type. So this will become my AsyncBufferView. So if buffer buffer refs increment, otherwise we decrement the reps. If buffers, let's assert you're not doing anything wrong, like buffer refs should never become less than 0. So we will get an assertion. I think I also want to assert that you're not passing like an invalid buffer ID. I prefer this to be assertions and not errors, because these are really logical errors. You should not be using a buffer ID that has expired. That's like a logical bug. You need to be fixing that. So assertion is good. I want to be able to get data. Maybe this should be fallible, maybe with a result. So you get a buffer ID. Span char data. So I'm going to take the buffer using the buffer ID and buffer data. Data equals buffers data. Yeah, if buffer return result true, otherwise return result error, invalid buffer. And what else do I need? I think I need, well, we'll see. If I need a way to size the buffers, probably yes. Let's go to the readable stream. What do I need for the readable stream? I need a way to create a queue of buffer IDs, but I don't want to have any dynamic allocation. So yeah, the idea that I had, because I was already thinking about this, is to have like a circular buffer, which we don't have. So I can create like a circular buffer, of course, always fixed size. So we'll have a span t buffer, and we'll make it template. So this will need to be done inside some sort of test. Let me do it here. Void circular buffer. That's going to be a long video, guys and ladies. So yeah, I will need a circular buffer for sure, but we'll do like a simple one, like just read index and write index. Circular buffer, I think I coded it many times. The easiest way to do it is to basically use just one less than the number of slots in the buffer, so you don't need to be tracking with some boolean if the buffer is full or empty, because you know that when read and write index are the same, then it's empty, and when it's not, there is something in the circular buffer. And when the write index is about to become, if incremented, becomes the read index, then you're full. So that's a lot easier to reason about. So let's make it bool pushback value t value. So let's compute it. Next write index, and we can make this to be write index plus 1. Of course, this is a circular buffer. We need to make it wrap under buffer size in elements. So if next write index is equal to read index, then we are full. We are full, baby. Otherwise, we can say buffer buffer dot get next write index. Yeah, equals value. We can probably move it. Not template named span. Let's include span. Include foundation span. Oh, that's S. Oh, I'm not in the SC namespace SC. I probably should have been making it Sane SCPP, but you know, way too many characters to type, so we'll stay with SC, and then, you know, we like C language, so why not? So this looks like a decent pushback, and then I need a pop front value. I want to write the value. So I need to check if we are not empty. So if read index equals write index, then we are empty, baby. Buffer get read index value equals buffer read get read index. Yeah. We can zero it. Maybe we can move it. Yeah. So we don't need to. Oh, I've been touching the microphone. Hopefully you didn't get blasted by the volume. And we can return true, right? Let's move it also here. This looks decent. Can we say like boolean no discard is empty? We can say, yeah, read index equals write index and is full. We can say, yeah, if this one equals read index. Yeah, sounds sensible. All right. Okay, I will make a circular buffer of integers. So in my data, we'll make it 3. 1, 2, 3. Actually, let me initialize them to 0. Then I will make a circular buffer of int buffer, circular buffer. I think I need to create a constructor here. Yeah. Oh, it's buffer probably. Circular buffer my data. Circular buffer pushback. We'll just make it like 1. So test expect that circular buffer is empty. Then I want to push 3 things, 2, 3. And I want to make sure this is full. Yeah, I want to expect that all of these are succeeding. And so these are succeeding. Sides elements, sides in elements. Yeah, the sides. What am I doing wrong? Oh, there's a sides conversion. Maybe I can make everything sides t then. Yeah, let's make it sides t. Expression is not assignable. Oh, yeah, I'm not returning double. No, maybe that's why. Okay, yes, return true. This is okay. I don't know why I was having that file system watcher test on the screen for this entire time, but yeah. Let's call the circular buffer test from here. If test section circular buffer. Circular buffer. Let's see. We are failing to say it's full. And why? Do we need a parenthesis here? Let's see, circular buffer. What is the read index? Oh, 0, I'm not incrementing it. I'm so bad. I'm really, really bad. So Right index is next right index. I'm bad, really, really bad. And read index should be incremented. +1. Of course, this should be wrapped into the buffer, into the circular buffer, so we don't need to yeah, we are not going out of bounds. So pushback 3. Oh, that's correct. That's correct, because we are only using up to n-1 elements. So otherwise this becomes a lot more tedious to code. I think this is fine. So this now works. This should not be working. Okay. And I should be able to pop front value and my value should be 1. What am I doing wrong? Oh yes, value. I should be passing value. Yeah, just missing some dereferencing operator here and there, but it's fine. I should be able to do 1 and 2. Should be able to do a third one, and this one should fail. Now, as soon as we pop something, this should not be full anymore, and we should be empty here, right? We have been popping everything. So value is still 0, so I'm not writing anything. Why? Pop front is not even coming here. So read index. Read index, where is the read index? It's 0. So value is buffer read index, which should have a 1. And it doesn't, because I'm doing something wrong. Yes, because I should be writing at right index and move to next right index. Okay. This looks like a super solid circular buffer, guys. That's going to serve us for what we need. So I'm going to place this into CircularBuffer class, CircularBuffer.h. Maybe this should go at some point into the foundation. I don't know. Don't know if this should really be like a general purpose class. Maybe not many people will actually need or like a fixed size circular buffer, especially it's not even multi-thread safe, so it's not probably so interesting for like as a general purpose thing. Let's give it here into internal for now, and we'll eventually upgrade it to become like a public class later on. Now we need to start doing the readable thing, and this video is extremely wrong already, but we can try, and if I can't really make it, I can eventually continue. Static const int num listeners, max listeners. So I don't hard code the number of listeners. At least I have a single place where I can change it. So this will need to be my data event. Cannot form a reference to void. Okay. Oh, I should not be making it void. How can I make it? Huh. Interesting. Oh, I should just not do anything, right? Event data, because yeah, I have variable. Yeah, varargs, not varargs. What's the name? The again, I never remember the name of this feature. Like variadic templates, could it be? So event data, we have event and we have, yeah, I mean, I think I've been writing them here. No. Well, we can do the same as Node.js. Node.js says data is and, well, it has many more, but we'll start with the most basic ones. And we need to have our start. We will have the destroy. We will have the pause. I don't know if all of them should be fallible, but yeah, why not? We have the resume. I want to have a function that takes a void, async read. We have our push with a buffer view ID. We have push and we have, what else? I think I can copy all of these, yeah. We need reactivate and emit error. Reactivate. Emit error. Yeah, so we need an on error. Event max listeners. Event error. This is clearly a result parameter. So emit error is pretty easy to implement. So it's just event error dot emit with a result. Too many arguments. Why? Not matching. Huh. Why this is not going where it should be? Event and. Yeah, why not? Yeah, I'll just make it move, not even forward. I mean, I can make it forward. So, emit error, it was not difficult, we can make it. Now, start. We need to save our CircularBuffer of buffer ID. So this becomes our read queue, and we can initialize it here. We have an init. We'll take a span of AsyncBufferView ID. Buffer. So I can initialize the read queue with this buffer. No, I don't have an overload. Where is my circular buffer? Oh, I've been hard coding span of int. Okay, return result true. Now, I also need a reference to the AsyncBufferPool, right? Buffer pool. So I can make it, yeah, I need to make this a pointer. Buffers equals pool. Okay. So I can say AsyncBufferPool get buffers, return buffers. Now, let's see the state machine. I can say enum class state. I can state equals state stopped. It looks legit. And we can initialize after init, we can say state is can read. That's what we said before. From stopped, we go into the can read. So we start stopped and we go into can read. But once we start, we go, I think we are probably needing to make this another method. Execute read, I don't know, because once we start and we execute the read, we need to be able to do it also from the resume. So probably better wrapping it already as a separate method. Execute read. So what should the execute read do? I think the first thing it should be doing is going into the reading mode, right? Is it the reading mode? Yes, reading mode. And then we need to loop. We need to start looping and call async read. So async read needs to be made fallible. This should return a result. Async read, yeah. If result, we do something else, emit error, move res, right? We definitely break it here. Instead, if state is, which one is the one that loops, sync read more, we continue. That's the only case in which we continue, right? Because this is it's basically like a synchronous loop of like read, provides data. Somehow this callback says, yeah, I want to provide more synchronous data. For some reason, I don't know what, doesn't make much sense, because I mean, you could have been providing it during the callback anyway, but I think this is for now is the best approximation of what Node.js is doing. So let's do it like this. So when I'm here, maybe I should switch. So state sync read more, case state sync read more, we continue, and case state, if we are still reading, then I think we can go, basically that's like the asynchronous case. So we can go, let's see, we can go into a sync reading state. Okay. I don't think this should be happening. Well, let's place some assertion where things should not be happening. Cert release false. So things that are unexpected will just be asserting and I can review them. Okay. Then what else? I think that's a good as a start. Well, you may be living into an ended state, in which case it's fine. You're just going to leave this in even the destroy. Yeah. These are fine. Well, we'll see. We will be hitting the release here, but as I said, the ending and the destroyed state will need to be added everywhere because you can destroy and end the stream in any moment. So that should generate a line basically to every other state, and I don't want to draw that. I will add it as we go, hopefully, and maybe I will have some bugs and I will fix them. Okay. So what do we do when pushing? When pushing, so I want to be pushing into my queue, which is my read queue, push back my buffer ID. If not, ras will emit error ras, and I will return no viable conversion. I can just make it like this, then emit error, result error, async readable stream push dropping buffers. Then I can switch depending on which state I'm in. I can be in reading state, in which case I'm going to go into the async. Sorry, no. Let's say we are in synchronous case, so we will go into state sync pushing state. And I can go in case state sync pushing yes, I can come back here in state pushing. I've not been drawing it, but yeah, you can definitely go back into state sync pushing if you continue to push multiple times synchronously. So sync pushing, for now this is good. Pushback, yeah, we need another pushback. It's just the reference. Default, let's emit error unexpected state. Now I should probably start to create some sort of test so I can, because it's becoming a little bit complex figuring out this. Even if I wrote it down, if I don't have a test, I think I'm going to get very confused. So let's start writing the test. If test section readable sync stream readable sync stream. I don't think I will be able to do the async stream for today, but Let's try to get at least the sync one going. Void async. Where should I do it? SC async stream test. Readable Async stream. Async Readable Stream. Readable dot async read. That's our lambda. Yeah, we need to return a result. Result true. Readable start. Yeah. So we need to init the readable, we need a pool, and we need the buffers. So the pool, async buffers pool dot buffers is buffers. So where are our buffers? I can make async buffers view id buffers num buffers, and I can say that I have two buffers, and I'm getting confused. What should I be passing to the buffers pool? Oh, this has buffer views, not the buffer ID. Okay. So I need buffers, buffer IDs. And like this. Right. Okay, we also need to initialize the buffers, so let's create like a heap block. I've made a class like heap buffer, which I can include here in the test. Heap buffer. Where am I? Heap buffer. Heap buffer. Heap buffer. Oh, I don't have a size of the buffer. Allocate and release. Well, that's all right. I will be able to allocate a kilobyte here. Let's split the buffers. So IDX less than num buffers. I can say buffers IDX equals heap buffer dot data. How can I split it? Slice start length offset in elements IDX times, yeah, let's do like this. Static const exp in buffer size, it's 512, and I can say buffer size times num buffers, right? So I have my buffer size, and the destination should be buffer idx.data. Oh, why do I have that buffer ID? That's not needed. Ignoring value of no discard. Of course. From int to size type. Okay, so we are taking this heap buffer, which is, number of buffers per buffer size, and generating this buffer views by taking this, data span and slicing it into equally sized buffers. So it looks complicated, but it's really simple. And I'm creating a buffers pool and initting my readable. So I can create my context that I can grab here. And my context, it's going to have size t, ADX, size t max. Yeah. So we can count to 100. So we can say context.id if context.idx is less than context.max. We call, we also need the readable. So async readable stream readable. I'm gonna make 0 and readable. Context.readable push buffer ID. So we need a buffer ID. Context.readable get buffer or pause. I don't know. Yeah, we need to be able to get a buffer, or we should be pausing if back pressure has been telling us to do so. AsyncBufferView ID buffer ID. If get buffer of pause buffer ID, we will be pushing. Otherwise, we will be pausing. So we need to implement this get buffer or pause. Result get buffer or pause. AsyncBufferView ID buffer ID. So we can see pool. Where is our pool? If get new buffer. Oh, we need like a size argument. Minimum size. Minimum size, then we return result true. Otherwise, we'll return, we'll be pausing. Yeah. Get new buffer. So we need to be able allocating a buffer. Result get new buffer. Maybe I can just make it. No. Oh. Yeah, let's make it like this. Get new buffer. I should just be looping all buffers. AsyncBufferView buffer in buffers. Do I support this here? I can say if buffer.refs is 0, buffer ID is I should probably make this, yeah, int32t idx less than buffers.size in elements, which I already know it's going to be size t. So I'm converting it. Buffer ID should be now buffer. Oh, it's just our IDX identifier. We don't have refs in strong ID. Sure, because we need to say buffers dot get IDX. Actually, I think I have been adding a call operator. Sorry, the parenthesis operator. Implicit conversion to size type. So I can make this size T. And I'm going to get rid of this one here, but this will complain down. Let's make it like this. Now buffer available. IDX is 0. And we want to be, is my camera actually still, yeah, this is still working, hopefully. I'm getting lost. I need a size the minimum size. So if we take this and buffers IDX dot data dot size in bytes is bigger than a minimum size, we'll make it. Okay. Get new buffer. Too many. Get buffer pause. How big should it be? We want to be emitting size t integers, so size of size t. Yeah. Probably also need the data. Yeah. Let's do like this. Data is buffers IDX dot data. Right. So span chart data. Data, we can copy our integers now. Context.idx plus 1. And we can copy it. Context dot. I'll just memcopy here. Memcopy. Destination is our data.data. The source is context.idx. Size of size t. So that's where we are emitting our data. And yeah. Otherwise, we are pushing the end, which is not implemented. So let me go there and say, for now, just state ended. Yeah. I think we need to have a switch here, because in some cases you may not be able to go into the ending state, but for now that's all right. Yeah, so we start. What can we expect? We can expect that is ended, which we need to implement. So bool is ended, const return state is state ended. And I need to listen in the onData readable event data. So our event data will get AsyncBufferView ID of buffer ID. I will be grabbing the context. Event data definitely needs to emit an AsyncBufferView ID. No Yibber overloaded. Why? Oh, I need to do add listener. Okay. Add listener. So, yeah. Not readable. I mean, I can just take the buffers, the pool. So pool dot, what can we do with our pool? Ref buffer get data buffer ID data span chart data. And then I need to be maybe converting this back to an integer. So let's say I have a vector of size t integers. And expect. So I need to, yeah, I need the context. Let's do another context. I mean, I could be using this. I can use the same one. Why not? I don't have the pool anymore, but I can say context readable get buffers get data, right? Okay. And now I can read the data. Value source is data.data, and this is data size t. Size t value. Mem copy. So we have the value. We can take the context and push back the value in the integers. I mean, I don't need to test expect this. And after it's ended, we should have, so event data is not even emitted yet, I think. So, okay, let's do void emit data. So if red q dot pop front buffer ID emit data with buffer ID, assuming we have an AsyncBufferView ID, buffer ID. Too many arguments, expected 0, emit data, event data. Does not provide a call operator, so we have emit to call, reference to buffer ID, let's do it like this, right? That's terrible. I need to make this better. But for now, multiple overloads of emit instantiate to the same signature void. What am I doing wrong? I need to fix this, but I don't want to fix it now. Okay. You can just say result. Yeah. I'll make sure to fix this with the proper level of ampersands. Now. So push should be pushing in the read queue. If we are in the sync reading or sync pushing state, I need to emit data. And that's going to be fine. Emit data. Yeah. Are we even arriving here in the Readable Async stream? Yes. Go. Is not ended. Why? Because we are never... Oh, we are not getting reactivated. So how many times are we coming here in the async read? Not even once. Oh, that's beautiful. Because start is not... So start should be putting us in state... Well, we can just call execute read. Maybe you should be asserting that we are in state can read. Yeah. You know what? We should be also readable event error, listening to the on error, add listener, so that we can assert any error. Okay. That's something. We at least arrived here. So we have our data. No, data is not filled. Get buffer or pause is not filling the data. So no, maybe pause should not be failing, which we still need to implement. And here should return false. Here this is true, and this should be okay. Get new buffer. So we had no buffer available, right? Oh, we have one. Ref true, return true, push, mem copy. We don't have any data here. Do we have any data at least here in this buffer views? Yes. So why are we not copying it anywhere? Buffers. They should be good. Let's see. Data equals buffers IDX data. Yeah. looks correct. Okay, return result true, return true. So data. Oh, that's the problem. Where is the ampersand? Okay. That's better. I mean, we are going forward. What state are we in? Sync pushing. So if we are in sync pushing, that's we should just break. Okay. Which is wrong, but yeah. Should at least get us in the outside of this crashing release assert. So when I'm here, I want to reactivate, which is not implemented. Switch. So if we are in state sync pushing, we will go in state sync read more, right? If do reactivate. If not, so probably, yeah, I should be deciding this here. So we force the user to call the reactivate true or false after they push. Or not. Let's see. State equals can read. Yeah. Otherwise, you go back in the can read state, right? Let's see. Sync pushing. You go in the can read, or you go in the read more, or you go in the ended, of course, but unexpected state. Which state do we have? When we are in push, which state are we in? Sync read more. Okay. Because when we are in sync read more, we want to be back in state reading. This is better. Okay. Well, that's probably, yeah, I think that's probably what we're going to do for today. It's been tough, I should be honest. I was expecting this to be a little bit more smooth, but for now, that's very, very complicated state machine. I think I still need to finalize this async reading, pushing, and state and ended state, even the pausing and paused. So I think for this video, I'm going to stop it here, which I already said. The basic synchronous, yeah, I mean, if this is called 100 times, the basic synchronous cycle looks like it's working. So maybe we can just count how many times it's being, yeah, it's being called. So context dot num times called. Well, I should probably add all of the values and check all of the values. Yes. So let's do that, maybe. So for int 0 to 100, context integers should be good, bold, good, true, and expect good. We always need to expect good things. Let's see, access element, and yeah, fail good. I fail good. Na 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 na. Why? I mean, what do we have in this integers? Context integers size 100. Oh, the first one is really bad. Why? Oh, this is not written then. Why? So we arrive here. Oh, the first one fails. I mean, why are we? Oh, because I'm pushing before even writing the data, right? That doesn't look correct. Yeah. So I think that this is fine as, you know, initial synchronous stream test for now. I mean, we are just pushing a list of integers and expecting that that's what we are getting, that we go into the right ended state. I think it's a good infrastructure. I will continue in the next video trying to add like the asynchronous portion with a different test and maybe cleaning this up a little bit, which we can do here by saying format source files. So yeah, I should probably regenerate this also. Generate and format source files. But anyway, that being said, thank you for listening, and I hope you enjoyed this video, even if it was a little bit confusing in some phases. I promise I will make like a recap of what has been done, and I think everything will become more clear as I proceed into this craziness of making asynchronous Node.js style streams in Sane C++. See you next time with Sane C++ libraries. Goodbye.